Promised, here's the last problem on the notes that we were doing on Thursday, and then we didn't get to. Like I said, most of you guys figured it out anyway and already knew what we were doing, but I want to go through it and so you have something to look at again before the test. So let's talk about this again. This is a logistic growth model. There's a carrying capacity of 99.744, which is the percentage of companies reporting usage of Microsoft Word. That's the max it could ever be. The growth rate we grab from the exponential function right here, e to the negative 0.799t. So, what is the growth rate? That's 79.9%, which is actually a very high growth rate. What was the percentage of Microsoft Word users in 1990? Well, by hand, we want to know the percent when t is not 1990, because t equals 0 is 1984. So if 0 is 1984, to get up to 90 we get 6. So I want to know when t equals 6. So you just plug that in, and again, this is the work I require. And then write out the... Okay, plug that all into your calculator, and you get approximately 97.316%, just 3 years late, or 6 years after 1984. Okay, and then during which year is it 90%? Alright, during which year is it 90%? Now I'm going to do this one by hand, and then I'm going to show you how to do it on the calculator as well. So C, I want to know the percentage when the percentage is 90. I want to know the t value. So we are looking for our t value. So in order to solve for t, we're going to have to use logs. But first, we're going to have to cross multiply here, or multiply both sides by 1 plus 3.014 e to the negative 0.799t. So we get 90 times this. Alright, sorry about that. Then we got e to, again, the negative 0.779t equal to 99.744. So the next thing you can do is divide by 90. Alright, and I'm going to leave it as a fraction right now. And I actually wrote that wrong. That should be a 9. When you divide this decimal by that number, the exact number is 2078 over 1875. And then finally we subtract the 1, so that minus 1. And again, you can use your calculator to get all these values. Divide by 3.014. Okay, so you basically got e to the negative 0.799 is equal to 0.03592. That's 5 decimals. Now we take the natural log both sides. This comes down and becomes negative 0.799 equals the natural log of this decimal. And when you divide that, the natural log of 0.03592 divided by negative 0.799, you get t is approximately 4.163. However, what it says is during what year? So we've gone 4 years, we're in the middle of the 4th year. So 84, so 85, 86, 87, 88, during 1988. So reached 90% during 1988. Alright, so that is the answer to C. Now, if you were to do this with the calculator, you type in your equation on y1. So I would say that this is my y1. I would say that this is my y2, and I look for the intersection point. Okay, so if I do that, let's look at the graph. Alright, here's my graph, but I need my y2 of 90, not 0 now. And I graph it. There's the model. Goes up really fast. I used a window of 0 to 10 in the X and 0 to 100 in the Y because the carrying capacity was almost 100%. Second trace 5. Enter, enter, enter. And sure enough, there it is. That's the answer we just got, 4.163 for our T. So I would need that graph. So I would need something that looks like this. The line 90 and the intersection point 4.163 comma 90, and this is my T value in the percent. Okay, so that would be what I needed to see using the graphing calculator. Y1, Y2, and then what the graph looks like, and then write down your answer down here and see again. I still need it written out. What did it do? It reached 90% during the year 1988. Okay, so I hope that clarifies some things. Again, C, very important to know how to do by hand. Also, just solving that problem. All right, good luck on the test tomorrow.